Okay, evidence for evolution. Explore number 2. How do scientists explain gaps and sudden appearances in the fossil record? Go ahead and do your normal, set up your template, and tell me what you know or think. Pause the video. All right. So, gaps. Uh, when you expect to have a consistent record, an accounting of every minute or year, millennia, whatever it is, and in fact, you end up missing a record for a certain portion of time. That's what they mean by gaps. Um, well, the fossil record has gaps, and the fossil record also, it appears to be at times where you see just a sudden flurry of new species that show up all of a sudden. And you have a hard time explaining it because you don't see anything preceding or leading up to that moment. And that's what they mean by sudden appearances in the fossil record. So, Roman numeral 1, evolutionary change appears to occur at a slow rate, not a constant rate, but definitely most of us think of evolution as being a slow process. Um, there are periods of stasis, letter A here, that is where you really don't see much change of anything. Or maybe it's very slow, the change that you see. But at other times in the fossil record and in evolution, there appear to be periods of rapid change where changes occur fairly quickly. So that leads us, those are just aspects of the fossil record that are observable. Letter C, gaps and sudden appearances in the fossil record. What would explain some of the gaps? You maybe already have some thoughts to yourself about why there would be gaps in the fossil record. It's pretty hard to form fossils to begin with. You have to have a lot of the right conditions. For example, you have to not be eaten, right? You're not going to form a fossil if there's nothing left to turn into a fossil, right? So that's an important part. You're fine there. Conditions then, you have to have rapid burial of your body. That will minimize the amount of decay that occurs. Rapid burial of your body that eliminates oxidation, eliminates oxygen, because your microbes, your bacteria, they need oxygen, and they're some of the primary agents for decay. So if you deprive them of their oxygen, then they are going to have a hard time decomposing you, right? Or whatever the organism is. You have to be buried in an area where there's minimal environmental disturbance, right? You don't want a herd of T-Rexes running over you, right? Not going to leave much bones left to turn into fossils. You have to, if you're going to be buried in sedimentary rock, it needs to be, the right temperature. You don't want it to be too hot. That might destroy the fossil. You don't want it to be under too much pressure. That might crush the fossil. And you certainly don't want to be laid down in sedimentary rock that's headed for a subduction zone, right? Or else you're just going to be turned into magma, and there'll be nothing left. So natural events such as erosion, subduction, all these things can destroy your fossils. So as you can see, you do need quite a few special conditions just to form your fossils. And this would explain then why we see gaps. It's pretty rare to find a fossil, right? Because a lot of times they're just destroyed. Letter D here. The Cambrian explosion, a sudden explosion in the diversity of life that occurred about 550 million years ago. i.e., many types of animals with different shapes and body plans start to appear. We're starting to get into something more than just multicellular or single cellular. I don't even know if I want to say multicellular. Um, they were very small if they were multicellular organisms, right? Their bodies were very soft, no hard parts at this point. Um, the Cambrian explosion is really well documented in Canada, up in the British Columbia, I think, province. It's called the Burgess Shell over there, is one of the best fossil records for this period. Okay, but in either case, there we see that life suddenly seems to explode from these single-celled, very small organisms to something more elaborate. Okay, um, in the grand scheme of things, this was a fast event occurring over tens of millions of years, right? Um, some of the thoughts as far as why we saw such rapid speciation was that we had a lot of raw material to draw from, right? There's plenty of evolution and organisms that had been flourishing. So you're kind of developing your toolkit of DNA hacks, right? Coding hacks. So maybe we just had finally gotten to a critical point, where we had enough DNA to pull it off and start to do this diversification. Um, One of the things they did notice also when you're looking at the Cambrian explosion is that prior to that, there seemed to be a sudden disappearance of many life forms in the fossil record. And of course, um, if you recall, this would be suggestive of a mass extinction when you see a sudden disappearance of many life forms on Earth. Okay, and let's see here. If we're still number 3 there. One of the things you want to keep in mind is when you do have mass extinctions, you eliminate a lot of competition, a lot of animals disappear. So you have an ecosystem or environment that is unoccupied. There's a lot of niches that are made available to whoever survives. And so that kind of stimulates the rapid speciation, the forming of new species. Um, and we right down there, this would have opened up ecological niches. Yeah, we talked about that. So Precambrian fossils are relatively rare. That's due to their soft bodies. It's hard to form a fossil if there's nothing hard to fossilize. Versus Cambrian fossils, where hard body parts, i.e., shells and bony skeletons, are we start to see those during the Cambrian fossils. So we have a pretty good collection of Cambrian fossils. Why do hard body parts form? Your text kind of delves into this a little bit. Perhaps Earth had started to form the right kinds of minerals in quantities that were available for these life forms. That would be thinking calciums and phosphates and magnesiums, that kind of stuff there. It's possible that with the development of eyes, all of a sudden you had one more tool for predation, and so it became an arms race. If you were the prey, you needed to very quickly develop ways to protect yourself from predators, right? So these are all just hypotheticals, hypotheses that people have, as far as why we start to see the hard body parts form. Roman numeral 2, punctuated equilibrium. This is the idea that even though you can have periods of no change in the fossil record, evolution just appears to be slow. That's what we call stasis. There are times after that where it's interrupted or punctuated with short bursts of speciation, relatively short, quick spurts where you see just a lot of change after seeing no change at all for a long period of time. This is the idea of a punctuated equilibrium. Okay, and that is something that would fit the fossil record. It would kind of explain some of the things that we see. So anyway, the purpose of this lecture was just to kind of explore the idea of the gaps and the sudden appearances of fossils. And hopefully we've been able to do that for you. All right, write down a summary paragraph and we'll talk to you soon.